This. Okay. Yes, good morning, good morning, good morning. So I hope all are fine. And yes, you were waiting for a long time. Some problem was there. So so today we have some important topics and important topics also. Important type of questions we are going to discuss. Okay. So now, first thing that we are having here, that is your radiation in your heat transfer. So in heat transfer, conduction is there, convection is there, radiation. Okay, so radiation part we are going to discuss. So in radiation, basically, okay, first thing that we have to, okay, you have to know that is your okay, Stephen's law. Okay, and I hope everyone have idea about the Stephen's law. So I can say here in this one, okay, what Stephen basically said, that amount of radiation emitted from body is basically proportional to T power 4. Okay, T power 4 is the keyword that you have to remember here. In Stephen, amount of radiation is directly proportional to T power 4. Going to write the formula here, but T power 4, because whatever the numerical will come, that will be based on this single line T power 4. They will say the temperature double, temperature triple. So we can say here in this one, that formula is basically Q equal to E sigma A T power 4. This is the total, okay? Total radiation emitted from the body is given by this formula, that the E sigma A T power 4. Okay, here we can write in this one T also for, okay, yes. So we can say E sigma A T power 4. E, you know, that is the emissivity, sigma Stephen constant, A area of the body. Okay, like this is the body here. This body is kept in this, okay, room, suppose. So we can say this area of the body. Here we can say area will be as 4 pi r square for the body. And T is the time and capital T is the temperature. No video. Where? In which campus? They will resolve. So we can say here in this one, formula you have to remember, and you have to remember area is not pi r square, area is 4 pi r square, surface area of the body. Okay, so E, we know that is your emissivity, sigma Stephen constant. A, that already we know, or told 4 pi r square. For this spherical body, most of the time they will give surface area. Okay, if with the suppose cylindrical body, okay, like this pen is there. Okay, so for this pen, okay, for the cylindrical body we can say here, okay, in this one, okay, what will the area here? Okay, so now we can say curved area. If you have to take only curved area, so curved area is 2 pi r l. Okay, this is the curved area, and plus pi r square for this one and pi r square for this one. If they say total area, if they say emission only from the curved area, then curved area you will take only 2 pi rl. Like if I say this is the bottle here, okay, so in this bottle, if they say emission only from the curved area, then we can say this is the your curved area. Okay, if this is total area, means you have to include this one also, this side also, as well as this side also. So your pi r square plus pi r square both side. Okay, this side pi r square, this side pi r square we have to add. So it becomes basically here your 2 pi r square. Mostly it will be the your spherical body. Okay, sometimes they can go for these things. You have to remember. Here ratio based question will be coming. So we can say Q1 by Q2 will be equal to your A1 by A2 into we can write T1 by T2 power 4. Okay. Now, lot of people remember in terms of radius that R1 by R2 whole square. A1 by A2 is not always R1 by R2 whole square. If they say that this is the your one, okay, cylindrical bulb and emission is only from the curved area, then we can say in this case length, they will say same. Okay, like this is the one and this is the another one, and they are saying length is same. So here we can say in this case only you have to take the, only you will take area will be coming here. If you take the ratio of area, only your R1 by R2, here R1 and here R2. So okay, you have to be careful in this one that what type of body they have given. This is the your spherical body or cylindrical body. Only these bodies will appear, and then you have to put here A1 by A2, T1 by T2 power 4. If they are saying body is same, okay, only temperature is changed, you are not okay having two different bodies, then we can say, we can write directly also that Q1 by Q2, okay, A equal to T1 by T2 power 4. I will take one numerical on this thing, then we'll go to, okay. So they will say here in this one, the temperature of the body is double. One body is there and then temperature is doubled. So if one body and temperature is double, of course we are going to use this thing, because you are not changing the area, you are only changing the temperature. So we can say temperature double. Then how we'll solve this question? I can write this side, and now we got here Q1, suppose initial radiation was Q, then by Q2 equal to earlier temperature, initial temperature was T, and now this temperature is your T2, means now we have doubled means 2T power 4, okay. So now we can say T2 power 4 becomes basically, so Q by Q2, here we can write, okay, 16, so Q2 becomes in this one your 16 Q, okay. Remember, here you have to convert always in the Kelvin. Sometimes what happens, they give the question, we don't convert in Kelvin, okay. Like I will take the next question here. They will say in this one, okay, I will take next slide for this. I hope this thing, whatever written here. So first of all, you need to remember formula in the Stephen. That your E sigma ATT power 4 mug up, okay. If I hope everyone knows this formula. If you don't know, then mug up this whole formula. If you're not able to mug up whole formula, then something like this E sigma A, otherwise T power 4, you can mug up area and T power 4. Area you have to remember for the spherical body 4 pi r square we have to take, okay, surface area. But if the cylindrical body like your bulb is there, cylindrical bulb is there, okay, then we can write your, if the curve area, this is the basically your curved area, and okay, then we can write pi r square total area here, okay. This is so 2 pi r square here. Now if I say question is here that body temperature was initially in this one, they have given it was suppose 227 degrees Celsius. Body temperature was 227 degrees Celsius, and now it is changed to, okay, they will say it is changed to, suppose some temperature I will say here in this one, we can take whatever temperature you want here, yes. Suppose we have changed this one to, okay, 727 degrees Celsius. Sometimes what they will do, basically they will give you the temperature in which you will get the your okay. So now we can say this one T1 will be how much your, in this case we can write here 227, and okay, so we can write you will add 273, so it becomes basically your okay 500K, and here this is your 1000K. And now question is nothing for you, because you can say Q1 by Q2 equal to here in this one T1 by T2 power 4, and we got the answer here, okay. Yes, like suppose if I give you, okay, this is for you to try, okay, you have to try this one. They will give you in this one 273 and 546, okay, 273 degrees Celsius to 546 degrees Celsius. 273 degrees Celsius to 546 degrees Celsius. If you say here in this one, then temperature, it will appear to you it is directly double. But can you take this one double? No, you have to convert this one into Kelvin, okay. Lot of people think, okay, 273 to 546 directly double, okay. You have to convert first in the Kelvin, then only you will take. So if you write this one, okay, you can add here 273, so T1 will become your 546, 273, okay. You can write here 546 Kelvin, and T2 you can write in this one 546 plus, okay, here also you will add 273, so 639 here, then you can write this is the your 1, okay, 11, so 1, and then 5 to 7, and then, yes. Now, and this ratio you have to find. If you say, okay, if I assume like this one, this is the X, then you can say this is the 2X, and this is the your 3X, and this ratio you have to consider, okay. 2X and this will be the 3X. If I take 273 as X, okay, we can say this is the 2X, this is the your 3X. So can you take the ratio here? Now we'll take here in the, this one Q1 by Q2 equal to, here you can say T1 by T2 power 4 means 2X divided by 3X power 4. Okay, so always remember to convert this one into your Kelvin. Okay, I have seen people doing mistakes in this particular question. 273 to 546, it appears almost, it appears double. A lot of people just take, okay, already double is given. So now next thing that we are having here, so these are the questions. Second thing that you have to remember, that if this body is kept in a room and if temperature of room is given, this body temperature is T, and suppose, so if body temperature is T, then we can say radiation from the body will be given by, okay, from this body radiations will be, okay, Q equal to, will write simple, E sigma AT T power 4. If a temperature of surrounding given, if temperature of okay, surrounding given, so we can say if temperature of surrounding is also given, surrounding is for this room, if this temperature of surrounding, okay, given here, suppose that temperature is T naught, then your formula will modify Q net. Okay, now because each body will emit also as well as absorb also, so if surrounding is there, we have to consider the net, and the net thing will be given by E sigma A T T power 4 minus T naught power 4. They will ask generally formula on this one. So formula you have to remember, E sigma A T T power 4 minus T naught power 4. If surrounding is not given, no need to consider T naught. This is your formula, and Q equal to E sigma A T T power 4. If you remember this from formula, where temperature is in the Kelvin, this is the 1 point, and A is the surface area, two types of body are coming here, you will be able to solve question from the Stephen. Any problem here in this one? Okay, so now we can say that E sigma ATT power 4, then net radiation, if temperature of surrounding, then only we have to take this thing, otherwise you don't have to take this, and area, surface area of the body, 4 pi r square, 2 pi rl plus 2 pi r square for the cylindrical one, temperature must be in Kelvin. Okay, I am going to stop this. Stephen is over for us. Okay, next thing that you have to remember here, that is basically in this one your Wien. Okay, Wien's law you have to remember. Okay, now what Wien's law is saying, this is a very simple law. Lambda m is proportional to, okay, 1 by T. Okay, lambda m proportional to wavelength proportional to 1 by T. Okay, so I will not explain what are the lambda m here. Right now you have to remember lambda m proportional to 1 by T. From here we can say lambda m will be equal to B by T. We can say lambda m T equal to constant. So we can say lambda m1 into T1 should be equal to lambda m2 into T2. This is the relation that you have to remember. Lambda 1 T1 equal to lambda 2 T2. Generally questions are coming on this thing. Okay, so we can say lambda 1 T1 equal to how much? Your lambda 2 T2. This part you have to remember. Okay, can you remember this thing? Lambda 1 T1 equal to lambda 2 into T2. So now I'll take one question on this thing here. And this also, of course, you remember that lambda and T relation is inverse. Okay, then I will tell the graphs here and numericals. So if I say lambda and T relation, then you can say lambda m and T. This is the your okay. So graph will be like this. If I say in place of lambda, if I write the frequency, means if I ask graph of frequency and temperature, then you can say lambda m is proportional to 1 by T, and lambda itself wavelength is basically given by, because you know your C equal to, I can write here C equal to, we can say lambda into, okay, nu. So from here I can say your lambda will be equal to C divided by nu, okay, proportional to 1 by T. So from here we can say nu m is proportional to T. So this graph will be your straight line. So these two graphs, first of all, you have to remember in this, okay, that lambda m is having inverse relation with the frequency. So we can say lambda is having inverse relation with the frequency. So frequency and time, temperature, not the time here. So frequency and temperature are direct relation, and lambda is having inverse relation. Lambda temperature inverse relation, and frequency temperature direct relation is there. Okay, so lambda and temperature inverse relation. So graph is like this. Whenever you have relation like this, one upper side, one downside, one up and one down, graph is like this. Okay, So now we remembered these two graphs here. Then I will go for third graph in this one that you have to remember in the vein. That is basically this graph here, okay? So in this one, this is the we take amount of radiation here, wavelength, and this is the basically your one graph, okay? This graph represents for corresponding to this particular wavelength, we have this much radiation. For this wavelength, okay, we are having maximum amount of radiation. So we can say here in this one that this wavelength lambda m is actually, okay, lambda m is the wavelength of maximum amount of radiation. Wavelength of maximum amount of radiation is basically lambda m, okay? If I increase temperature, then wavelength will decrease. If I increase temperature, at higher temperature, wavelength will be less. So this is the one point you have to remember. At higher temperature, wavelength will be less. So if I ask this question to you, at higher temperature, wavelength will be less. So now in this one, they have given one graph like this. One graph is given here. This is at T1 temperature, this is at T2 temperature. You have to tell which temperature is more, okay? So what you will say from the top, from the peak of this curve, from this peak you will take, okay, always. And from here you can say this wavelength will be lambda 1, because this is the T1, so corresponding to this we can say lambda 1. And from peak of this one you can say how much? Lambda 2, okay? Now you can say which one is basically more? You can easily say that, sir, lambda 2 is this much and lambda 1 is this much. Lambda 1 is more than lambda 2. And if lambda 1 is more, it means temperature is, okay, first temperature is less, inverse relation is there. So we can say T1 is less than T2, okay? So this thing you have to remember, okay, this relation, okay? Yes. Now I will go for the next one here. Okay, same question they can ask for the frequency also. So frequency question is very easy here. Like you can see in this one, they will give you the graph like this, okay, and this is given here. This one at the T1 and this is at T2. So what we can say that from the peak of this you will take peak, okay? You have to be very precise. Very precise, you have to take from the peak only. And now we can say in this one that this one will be how much lambda or your, okay, frequency, so nu 1, and from the peak of this one will be nu 2. And here you can say which one is more. Here clearly visible from the graph, your nu 2 is more, nu 1 is this much, and nu 2 is this much. So we can say nu 2 is more than nu 1, and nu and, okay, this frequency and temperature is having direct relation. So we can say in this one T2 is more than T1. So these are the graphs of Wien that you have to remember. I hope this thing is clear. Okay, 1, 2, 3, 4, 5. Okay, 5 graphs are there. More than this, nothing is there in the your Wien. Means graphical questions are only these. You have to do graphical questions and formula-based questions. First of all, in this you cannot do any mistake. Now I will take here in this one that if I take area of this curve, okay, so area of this curve means I am going to add up all the total radiation. I am adding all the radiation. So we can figure, okay, we can find here in this one, if you just okay, add up all the radiation, that will be equal to area. So area of the graph, okay, you remember, area of graph is always proportional to total radiation. Area is always proportional to total radiation, not area of the body, area of the graph, okay? In this graph, if I add all the radiation, which will be equal to the total radiation, so area of the graph will be proportional to total radiation. So we can say area of the graph is proportional to T power 4, okay? T power 4, because we know total radiation is proportional to T power 4. Total radiation is proportional to T power 4, okay? Now, can I give you one question based on this? So here we got one more numerical based on this. They can see the graph also, they can give the numerical values also. Like I'm going to add here. So this is the area of the graph, not the area of body. A lot of people do mistakes here, that this is the area of body or area of the graph. Area of the graph is proportional to T power 4. So they will give you area or they will ask question on the area, okay? They will ask ratio of area. They will give the temperature, they will give the wavelength. Otherwise, they will give you ratio of area, they will ask ratio of temperature. This will be the question. Like next question I'm giving here. They will say this type of graph will be given. and okay, T1 and T2. They are saying that this okay is E lambda. This is the lambda here. For this wavelength H, okay, this one is 360 nanometer, and this wavelength is 540 nanometer. Okay, 360 nanometer and 540 nanometer. Okay, they have given like this. This is the question. I will make it somewhat zoom. So 360 nanometer and 540 nanometer is given here. We need to figure out ratio of temperature. Ratio of temperature and ratio of area. This graph is having area A1. Okay, area A1, and this graph is having area A2, area under curve. Okay, area under curve A1 and A2. So we can say first of all that this one is basically lambda. Okay, this one is lambda 1, and this is what your lambda 2. Okay, so we can easily say here in this one, sir, lambda proportional to 1 by t, it means, okay, we can write here in this one, inverse relation is there. So T proportional to 1 by lambda. So T1 by T2, if you say, so T1 by T2 will be equal to much your lambda 2 by lambda 1. Okay, T1 by T2 we can say, because values are given here 360, 540. This one is T1, so T1 means corresponding to T1 you have written lambda 1. This is the your lambda 2, 360. Now we can say lambda 2 value I will put here in this one, that is a 360 divided by, I can put 540. And now you can see using okay 18. This is how much your 2 times, and this is how much your 3 times. So we got temperature ratio T1 by T2 will be how much your 2 by 3. I hope this one is clear. Okay, now they are asking, this is the first part. They can ask this one, that what are the ratio of temperature we got. Okay, they can ask a ratio of second area under curve. So area under curve A1 by A2, and you know A1 by A2 is nothing but T1 by T2 power 4. Okay, area under curve is proportional to T1 by T2 power 4. Okay, so we can say that we can write T1 by T2 power 4. First of all, from this relation, which is the Wien's relation, lambda proportional to 1 by t, so we can say t proportional to 1 by lambda. So T1 by T2 will be equal to lambda 2 by lambda 1. We got 2 by 3 here. So T1 by T2 will be equal to 2 by 3. Okay, area under curve, so we get it power 4, and now nothing is tough for you. 2 by 3 power 4. So you can say here, this is how much your 16 divided by 81. Yes, clear? This same question they can ask in the language form also. They will say like this, that when wavelength is changed from 540 nanometer to 360 nanometer, then ratio of wavelength like this. Okay, so language also can be given, we can figure out. Okay, can I ask next question now? Next thing. Okay, now next question they have given in this one, that when temperature of ideal black body is, okay, 927 degrees Celsius. Temperature is 927 degrees Celsius. Okay, wavelength, okay, or I'm directly writing lambda m. Okay, lambda m is basically wavelength of maximum amount of radiation. Lambda m is 5400 angstrom. 5400 angstrom is the wavelength. Which wavelength? Wavelength corresponding to the maximum amount of radiation. So wavelength corresponding to the maximum amount of radiation is your 5400. If okay, temperature is changed to T Kelvin, or T they have given here T, okay, then lambda m becomes 3600 angstrom. So you need to find T, what will be the temperature, and I have not given this one in the degree Celsius or Kelvin, so they can make option in the degree Celsius also as well as Kelvin. But when we are solving, we will get answer always in the Kelvin. whenever capital T word is used in any of the formula, we have to put in the Kelvin, and we will get always in the Kelvin. So now we can see lambda m1 into T1 will be equal to lambda m2 into T2, or you can use lambda 1 by lambda 2 equal to T2 by T1. That is the same thing. So initially it is a 5400. This is how much here? Your 927. You need to convert into Kelvin by adding 273. So if you add here in the side, I can write 927 and 273. You will find here your 1200. Okay. So I'm putting here 1200 equal to lambda 2. You can write here, that is given in this one, 3600. Okay, later on. So we can write here 3600 into how much your T2. So now we can say that 2020 cancelled, and this value how much your 3. So T2 you can say it becomes 5400 by 3. This will be in Kelvin. If they ask in the degree Celsius, we can simplify. Yes. Now you can do the calculations. Okay, so these graphs as well as numerical in the Wien, it is clear. Graphs and numericals are clear. Okay, very good. Now I will take one last question in the Wien. They will say, okay, again I'm taking the same values. Okay, same value I'm taking here. They are saying that wavelength from two bodies, wavelength from two bodies, okay, two identical bodies they have given. Okay, identical bodies means their emissivity is same, their area is same. Okay, surface area is also same. So identical bodies are given. Wavelength from two identical bodies is given. So identical body means area is same. Okay, and they are giving the wavelength as 36 nanometer and 540 nanometer. Okay, values can be different. I'm not taking different values, taking the same value so that calculation is clear in your brain. Okay, they can only change the values. They're asking find ratio of radiation emitted by them. Okay, ratio of radiation emitted by these bodies, we need to find the ratio. You can say radiation from the bodies Q1 by Q2 will be actually equal to T1 by T2 power 4, because all the things are same, identical bodies. They are saying identical bodies means area is also same. Suppose they have given this spherical body. If spherical body is given, then they will give you the radius. If radius is given, then we can put R1 by R2 whole square also. Along with this, R1 by R2 whole square. A1 by A2 is there. Now we can say T1 by T2 I need to find. You can say, sir, I can easily find T1 by T2 because lambda is given. So T1 by T2 you will write here. T1 by T2 is nothing but the lambda 2 by lambda 1. And listen these questions carefully. I'm not telling that these are the easy questions. These are the good questions, can be asked. Okay, like that area thing is there, graphs are there. Okay, so I'm not saying just easy things which are actually important and that you can easily do. Means if you just mug up also, then also we can figure out the things. So now we can say T1 by T2 is lambda 2 by lambda 1. So lambda 2 we can see here in this one, that the 540 divided by 360 here in this one. Suppose this is the first body, this is the lambda 1, this is the lambda 2. So now we can see here again, this will be 3 by 2 here, and we can put in this one 3 by 2 power 4. Okay. Yes, this is also over. Now next law that is there for us is the Newton's law of cooling. You have to remember Newton's law of cooling. Anyone having any problem? I have completed till now 5 slides from starting in this one. First I explained your Stephen. I said formula you have to remember. Then about the body type you have to remember, a spherical body or cylindrical body. Our surrounding is given, then we have to add just we have to just consider this minus T0 power 4. Then we have done this Wien, graphs on Wien. All the graphs are important. You have to do these things. Okay, and area of the graph is proportional to T power 4. And then we did this question on the graph where wavelength were given, and we got a ratio of temperature, we got ratio of area. And then next question was, they are saying in this one temperature was given, one wavelength was given, another wavelength was given, another temperature was asked. So we have done here lambda 1 T1 equal to lambda 2 into T2. And now this is the last question. In this one they are saying that two identical bodies, wavelength from two identical bodies, okay, and these are the two wavelength, 360 nanometer and 540 nanometer. This one we can say lambda 1, this is the lambda 2. So two bodies, like this is the body, this is your first body, this is the second body, this is emitting 360 nanometer and this one is emitting your 540 nanometer. So they are asking ratio of radiation emitted, and radiation emitted we know that is a proportional to T1 by T2 power 4, because they have given here identical bodies, and if body are identical, area will be same, all other things also same. And I have told in the Stephen, this one I am writing from the Stephen, Q proportional to T power 4. Okay, I said this thing only we can remember at least. So T1 by T2 power 4, and then we can say T1 by T2 I don't know, I need to find. So we can say T1 by T2 equal to how much your lambda 2 by lambda 1, and lambda 2 is how much your 540 by 360. So 0 0 cancel, using 18 we can say 3, here your 2, so 3 by 2 power 4. Finish. Then I will move to the next one. Okay, still if you have any doubt you can ask. I will go for means whatever important questions are there in your Stephen as well as Wien covered. Now we'll take Newton's law of cooling. Okay, so listen this one carefully. Newton's law of cooling. Okay, in short we say this one as NLC. Okay, what they say actually in this one, what Newton said, that rate of cooling is directly proportional to temperature difference. Means rate of cooling, if I say d theta by dt is directly proportional to temperature difference delta theta, or delta theta I can say basically, okay, theta minus theta naught, proportional to theta minus theta naught. Okay, this is the thing. Rate of cooling is directly proportional to delta theta. Okay, rate of cooling directly proportional to rate of cooling. Okay, rate of cooling, your d theta by dt, okay, is directly proportional to, okay, directly proportional to temperature difference. Okay, temperature difference between body and surrounding. Okay, so delta theta is the temperature difference between body and surrounding. This is the basically temperature of body, and this is the temperature of surrounding. Okay, now this is the temperature difference. So temperature difference does not matter here whether you convert in the degree Celsius, means you convert into Kelvin or you use in the degree Celsius. So here in this one there is no problem. That's why I'm writing here delta theta. Okay, the first question they can ask in the Newton's law of cooling, d theta by dt, rate of cooling is directly proportional to, okay, they will give options like this: delta theta square, delta theta cube, delta theta power 4. Okay, they will say this thing, rate of cooling is directly proportional to. So we can say, of course, he told delta theta. A lot of people use this one, that delta theta power 4. Temperature power 4 was given by Stephen. Temperature power 4 given by Stephen. Newton simplified, and Newton said it is proportional to only delta theta. So you have to remember, okay, that Newton told only delta theta. Stephen told power 4, temperature power 4. Okay, and your Newton told just delta theta. Okay, so this option will be correct. So remember always only delta theta will be there. Okay, not delta theta square, not cube, not here. Okay, Stephen, if they are asking, then Stephen told about power 4, Newton told about delta theta. It means here power is how much your? Power is 1. Okay, delta theta. They can say like this also, delta theta power n, where n is, we can say n will be how much your? 1, as per the Newton. Okay, now after this we can say here, then he simplified this thing. So I'm directly writing formula here, that this is the formula to remember, theta minus theta now. Okay, or well, right here, if they will give the question like this: if temperature of body changes from theta 1 to theta 2 in time t1, and okay, like this question will be given. Okay, so theta 1 to theta 2 in time t1. Next line will be theta 2 to theta 3 in time T2. So for this we have the formula here. Theta 1 minus theta 2 divided by T equal to K theta 1 plus theta 2 by 2 minus theta naught. And this is the formula to remember. Everyone now how to remember theta 1 minus theta 2 by T equal to K theta 1 plus theta 2 by 2 minus theta naught. Okay, so this is the formula here. Now you have to mug up this thing. Theta 1 minus theta 2 by T equal to K theta 1 plus theta 2 by 2 minus theta naught. Theta 1 minus theta 2 by T equal to K theta 1 plus theta 2 by 2 minus theta naught. What will be the basically? One line will be given like this. Temperature of body changes from theta 1 to theta 2 in time T1. So you will use this formula and then you will make one equation from this. Okay, theta 1 to theta 2 given. So theta 1 minus theta 2 by T equal to K theta 1 plus theta 2 by 2 minus theta naught. One equation will make. Then they will give another line. Then from another line we have to make one more equation. And then we have to solve these two equations. That's it. So can I ask next question now? Okay, so here question is temperature of body changes from 80 degrees Celsius to 70 degrees Celsius in 5 minutes and to 60 degrees Celsius in, okay, means 80 to 70 it is coming in the your 5 minutes and okay to 60 degrees Celsius in 10 minutes. Now this language is a little bit little bit tricky language here. Okay, lot of people do mistake in this one, that what is given here. So you have to read this one 2 times. What question is trying to say? 10 minutes, find temperature of surrounding. This is given, find temperature of surrounding. So you have to read this one 2 times at least. Read this one 2 times at least. Or I will take this question later on. I will take first one easy question, okay? Before I will take then this one. They will say, okay, a cup of tea cools from 80 degrees Celsius to 70 degrees Celsius in 5 minutes. Okay, what will be its temperature in next 10 minutes? Temperature of surrounding is given here 20 degree Celsius, or I can say 25 degree Celsius. Okay, so this is the question here. If you see, both question will appear to you little bit identical. That is, the previous one is also, first line is same, 80 to 70 in the 5 minutes. I'm asking what will be the temperature in the next 10 minutes. Okay, and theta naught is 25, but both questions are not same. So you will make always like this. Theta 1 you will write here. Here you will write theta 2 and here time t. Theta 1 means it is coming from 80 to 70 in your 5 minutes. They are saying in the next 10 minutes. So from 80 to 70 already it came. So 80 to 70 it is taking how much time? 5 minutes. Okay. 80 to 70 it is taking how much? Your 5 minutes. Okay. Then I can say 70 to 60. 70 to 60. Okay. No, they are asking how much. Okay. Not the 70 to 60. So now we know it will be coming from 70 to theta. They are saying now in next 10 minutes. Okay. If you say here it is given next 10 minutes. They're not saying in the 10 minutes. Next 10 minutes means 5 already completed. Now how to go for the next 10 minutes. 5 minutes completed. In 5 minutes I came to 70. Now they're asking in the next 10 minutes. So I can say I will be reaching here theta. Now from this we have to make the equation. So I can say first equation you will make from here. 80 minus 70, which is the 80 minus 70 I will write, divided by 5 equal to, you will say k, 80 plus 70 by 2 minus 25 surrounding temperature. Let me simplify. 80 70 is 10 by 5 is 2 equal to k. Here 80 70 75 minus 25, it will be the 50. This is the equation number 1. Okay. Now equation 2 I need to make from here in this one. So 70 minus theta divided by, you can say 10, equal to, we can say k. Here if you say 70 and theta, so we can write 70 plus theta by 2 minus 25. Now this one you have to simplify. You will suggest here, you can take this k from here. So k will be equal to much your 2 by 50 means 1 by 25. I hope this part is clear. Okay, so I will put here in this one, I can simplify here, 70 minus theta divided by 10 equal to k 1 by 25 here. Here also I can take LCM, so 70 plus theta minus 50 divided by 2. Now you can, okay, do this calculation. So I can say this is the 2. So this will be how much here? Or I'm not doing anything here. So 2 is kept as it is. So you can say 70 minus theta divided by 10 equal to, here I get 25 and 2 will be 50, and then I can say this will be, okay, theta, and this will be 70 minus this, so plus 20. Now this will be the 5, you can do the cross. Can you do this calculation now? Now we have to do this calculation, so I can say here in this one, that becomes 350 minus 5 theta equal to theta plus 20, 6 theta equal to 330, okay? 6 theta equal to 330, okay? So we can find easily your theta here. Done? Okay? So this is the one question. So I hope you can do questions like this. 2 equations you have to make. In this one, theta 1, theta 2, it is coming from 80 to 70 in the 5 minutes. So I have written here 80 to 70 in the 5 minutes. And then 70 to theta, because they are asking what will be the temperature in the next 10 minutes. So I can see yes, 70 to theta in the 10 minutes. And then written the equation as per the, okay. Now, previous question that I have written here, okay, this one. It is also the same question, but language is only different. Now just read the question here and, okay, figure out, okay, write like this, theta 1, theta 2, whatever I have written, and then check. I will write after 1 minute, okay, and then think whether you are right. If you are able to write these things correct, if you are getting the question correctly, you will be able to solve 100%. Temperature of body changes from 80 to 70 in the 5 minutes and to 60 degree in 10 minutes. Here word is not given next 10 minutes, in 10 minutes. So, can you try this one? Okay. Temperature of surrounding you have to find here. Okay. In this one, temperature of surrounding you have to find. Okay. Or I can make it not 10 minutes here. Okay. I can make it 15 minutes better. Okay. Then you can simplify. Okay. Calculation will be much easier. This is for the practice. Okay. Now I will take another one because now we have to do a lot of other things also here. It will. One question I will take here, you have to remember that rate of heat loss is proportional to area. Okay, rate of heat loss is proportional to area. More heat than okay means more area than okay more heat loss will be there. Like if you have to cool your rice or cool something, then you will always keep in the plate. So area more, heat loss will be more. Okay. Heat loss is basically dq by dt, which you can say dq by dt is proportional to what? Area. Can you remember this line? Rate of heat loss is proportional to area. So dq by dt will be proportional to A. Okay? dq by dt will be proportional to A. This thing we can remember. dq is your ms d theta. So ms d theta divided by dt, I can write proportional to A. So from here, d theta by dt is proportional to A by ms. So now we can say d theta by dt is how much your A by ms. What is the d theta by dt here if you say, okay, this one we got d theta by dt is known as rate of cooling. Sometimes these formula only they ask. Question becomes a little bit tough here, okay. So they have not asked in the NEET till now. In JEE they have asked. I will take one question which was previously asked in the JEE. But first of all, formula we need to remember: more area, more heat loss. Okay. In the winter time, animal curl, okay, they will curl like this so that they can reduce their area, so that heat loss is minimum. You have to cool something, you will always spread so that area is increased, okay, so that we can okay, heat loss will be more and it will be cooled down fast. So rate of heat loss is proportional to A. So dq by dt is proportional to A. dq I can write ms d theta by dt proportional to A. So from here we can say d theta by dt is proportional to A by ms. Rate of cooling is proportional to A by ms. Yes, rate of cooling is proportional to A by ms. Okay, so I'm taking here one question in this one, and you can simplify for a spherical body. If I say na, for sphere, okay, so for sphere we can say, okay, d theta by dt proportional to area will be 4 pi r square divided by mass will be how much? Your mass will be volume. Volume will be 4 by 3 pi r cube into rho into s. So for sphere, if you say, okay, for sphere, now we can say 4 pi is constant. 4 pi by 3 is also constant. What is left? So we can say rate of cooling for a sphere, because mainly question is coming from the sphere. If they're asking for cube or something, then this thing is written here. So for the sphere, we can say dq by dt will be, okay, means d theta by dt I can write here in this one. So d theta by dt will be how much? You can say in this one, really be, okay, 1 by r rho s. This formula only they ask for the spherical body. What the rate of cooling? So rate of cooling is proportional to 1 by r rho s. Okay, so only thing that you have to remember, heat loss. From here we can easily derive the things. Heat loss is A, more area, more heat loss. dq by dt is A. So dq I can write ms d theta by dt is your A, and then we carry out d theta by dt is A by ms. Okay, and then we can say area 4 pi r square, mass is your 4 by 3 pi r cube rho s. So we got here r square r cube r rho s. So based on this, I am going to take one question here, and I hope you will remember, bigger area, more heat loss. More area, more heat loss. We have to cool something, will always spread so that area will be more, and it will be cooled fast. Okay, you have to eat rice or something like this, then only. Now they are saying two spheres are there. This is the one, this is the sphere 2. They are made of same material. Made of same material. This thing is given, made of same material. Okay, this is the previous JEE question. I think in advance it was asked based on this formula only, and it is important, can be asked. Okay, so now we can say a little bit tricky. They have given m1 is 3 times of m2. m1 is 3 times of m2. Mass of first is 3 times of second. They can say some relation 2 times, 3 times, or 4 times. Okay, so some relation will be given for the mass. Okay, so m1 is 3 times of m2 here. Same material is given. If same material, then you know one thing is sure, that in this case density and s is same. Density s becomes constant. Okay, density and s becomes constant. Then you can say, if I have to solve rate of cooling, they are asking, so d theta by dt, basically rate of cooling I can say with the rc also. Okay, rate of cooling rc, so rc will be proportional to 1 by, okay, 1 by r. Okay, this d theta by dt or rate of cooling, okay, I can say your or rate of cooling only I can say d theta by dt. So d theta by dt will be proportional to r, because density and specific heat also constant. R you have to find. From here we can easily find the R, because you can say mass will be 4 by 3 pi r1 cube into rho equal to 3. 4 by 3 pi into rho. 4 by 3 cancelled, rho also cancelled. So we can say R1, okay, R1 equal to how much? Your 3 power 1 by 3 into R2. It means R1 by R2 if you say, so R1 by R2 becomes how much? 3 power 1 by 3. R1 by R2 from the mass everyone knows, mass proportional to R cube, na? Mass proportional to R cube everyone knows. If you don't use this, okay, thing also, directly you can say mass proportional to R cube. So R1 cube equal to 3 R2 cube. R1, okay, in place of mass, directly also we can say R1 cube equal to 3 R2 cube, and from here we can say R1 by R2 is coming 3 power 1 by 3. Now question is finished because we can say d theta by dt for the first body divided by d theta for dt for the second body will be equal to, in this one, R2 by R1. Reverse you will make, so it becomes 1 by 3 power 1 by 3 over. So this is the your all things in the radiation. It is finished. All important questions, even though they were a little bit tough, it's finished. Okay, easy things. Formula we have to remember, at least formula based question, because formula they will ask most probably like this, 1 by R rho S they can ask. Then we have thermodynamics. In thermodynamics, first of all, one thing is that everyone knows that if any of the graph is given, they will ask to find the area. So we can easily figure out the area if they have given like this one. So you have to find just a area of this. They will say what are the work. So we can say work is always equal to area. And area of this we can easily find, like this is the 10, this is the 20, this is your here I can say 5, this is the 10, this is the P, this is the V. So we can say area under pressure volume only gives the work. Work is the basically area under pressure and volume, because work is given by, if you know, work is basically integration of P dV. So area under PV graph is equal to work. If I say area under VT graph equal to work, area under PT graph is equal to work, which one is correct out of this? Number 1, number 2, number 3. They will give you that these statement that which one is correct regarding this. So now we can say in this one, only PV graph gives you work. Remember always, only PV graphs gives you work. This is correct, this is not correct, this is not correct. Only PV graphs gives you work. Then we can see here we have to find the work. So we need to figure out the area. So you can say, sir, this side is how much? 10. And this side is how much? Your 5. 10 and 5 is how much? 10 into 5, that is basically your 50. Yes? Over. Now, so if I give you any diagram, so diagram based questions, we can do your calculation of area. Now for other process, you have to remember, like if I say isochoric process, so W for the isochoric process is always 0. Like if I say the graph here in this one, P and V, and I have just drawn here 4. Now you have to decide in this one. First of all, that this line. Your breakfast is over. Breakfast completed. Okay. Listen. So we can say this one. This line is cutting the volume. If this is cutting the volume, this will be the your volume constant. Volume constant. So you say this is the W. Means isochoric. This one is known as your isochoric. So W isochoric is always 0, volume not changing. This one is cutting the pressure axis. So here pressure constant, and a pressure constant, that is the WIB, and this is P delta V or NR delta T. P delta V or NR delta T here. For the isobaric process, P delta V or NR delta T. Now these two are left, and for these two we have to tell. So you will just take one ball and release the ball. Ball going fast, adiabatic, because adiabatic process is fast. Like this we can identify. Ball going fast, it is your adiabatic. Ball going slowly, it is the isothermal. So if you release one ball here, and ball in this graph will be coming slowly, but here coming very fast, and fast is the adiabatic. So we can say this is the isothermal, means here temperature constant, isothermal, and for isothermal work is given by 2.303 nRT log V2 by V1. V2 by V1 means V2 is the final, V1 is the initial. And here we can say this one is the your adiabatic. So W for the adiabatic is given by NR delta T divided by 1 minus gamma. nr delta t by 1 minus gamma. You can do this thing using this also, that work here is equal to minus delta u. Okay, work is equal to minus delta u here. You can use this thing. Okay, here work is always equal to change of internal energy. In this process, work is always equal to q. Okay, work is always equal to q. Okay, here work is 0. Okay, here work is 0 because we know first law is there. What is the first law? Q equal to W plus delta U. So if you say in this one, here W is equal to Q, because here what thing is 0? Here delta U is 0. Here in this one, what is 0? Your Q is 0. Here if you say W is 0, so we can say if W is 0, na, then Q will be equal to delta U. This is the isobaric. In this one, nothing is 0. Okay, none of the parameter is 0, neither W. If you see all the other process, here your okay Q is 0, here your delta U is 0. Okay, here your work is 0, but isobaric nothing is 0. Listen, so here they ask one special type of questions. Work we can remember at least. Work and this graph, okay, you have to keep in the mind. Then here they ask one special question for the isobaric, okay, that in the isobaric work is this. If I say Q, then Q is given by always N C delta T. Q is different for different process. Like if I say Q for the, okay, Q at the your iso, okay, Q at the constant volume, so we can say N CV delta T. Q at the constant pressure, you can say N CP delta T. Q for the X process, we can say will be the N CX delta T. So Q is different for different process. But delta U, if I say delta U is N CV delta T, same for all. This one is same for all. For all the process, it is same. Okay, all the process, this thing is same. Done. Okay, this will be different. Work is also different. So work and Q different. W and Q different for different process. So this will be the basically your path function. Okay, W and Q are the path function. Delta U is the your state function. It's same for all. They will say like this. Okay, that at a constant pressure, Q heat supplied to monoatomic gas, what percentage of heat is used to do work? Means we have given some energy. Out of that one, some part of this energy is used for the work, some part of this energy is used for the internal energy. Okay, so at constant pressure, Q heat is supplied to a monoatomic gas. What percentage of energy is used to do work? Okay, means out of this Q, two things will be there. One task is the work, one task is your delta U. Okay, two things will be there, and now we have to decide Q. Okay, one is the work, one is the delta U. So we can say some part here, some part here. Okay, so we can write in this one percentage used for the work. For work, okay, we can W divided by Q into 100. Work divided by total energy you have given Q. So work divided by total energy Q into 100. Okay, so work is always given by NR delta T divided by, we can say Q is N CP delta T into 100. Now N delta T you can cancel here. So it's R by CP into 100. Okay, R by CP into 100. Now I can see here R divided by CP. CP will be how much your? And okay, we will be having break. Okay, so don't worry about the break, that you will not get the food. Food is very important. So we'll have one break. Okay, so don't worry about the break. At what time you want to break? So at that time we'll be having the break for okay 10 or 15 minutes. Okay, later on after this class will be over by timing is 10, but it will not be over by 10. It will be going up to 10:15. So that 15-minute time we will okay manage here. Okay, so that you can have your food is required, then only energy will be there, otherwise energy will not be there. Maybe after completion of this one, okay, this thermodynamics, then we'll, okay, because thermal physics, one important part will be over. After 10, no, after 10 will be much late, I think. So before 10 we'll be having, okay, that 15-minute we will utilize here, it will be better. So maybe around, some here near to 9 or just 8:40 we will, okay, have the break around 8:40. So R by Cp for the monoatomic, if you say, then monoatomic Cp is your 3R by 2, 5R by 2. What do we have to use here? 5R by 2 into 100. So you can say RR cancelled, and this will be how much? Your 40%. So 40% energy is used for the work. Remaining 60% is used for the internal energy. This question very important. So many times we have asked in our internal examination. They have asked in the previous year examinations also. Constant, okay, they can only change this monoatomic or diatomic. Mostly they are giving also monoatomic. And what percentage of heat is used to do work? So we can say percentage of work will be W by Q into 100. W is your NR delta T by NCP delta T into 100. Now R by Cp, so we can say Cp is how much? Your 5R by 2 into 100. That becomes how much? Your 40%. Okay. Remaining is for internal energy. If they say percentage of internal energy, we can say how much? Your 60%. Okay. Now, so I hope this one is clear. Work is NR delta T, Q is NCP delta T into 100. And this type of question are only possible in the isobaric. We cannot have these questions in the iso, okay, in this process, okay, not possible, because Q is equal to delta U. Total energy is converted in form of internal energy. No work is done. Here, okay, Q is 0. So work is equal to change of internal energy, negative of change of internal energy. Here your internal energy is 0. So heat supplied is equal to work. Okay. So this type of question is only possible in your, okay, means isobaric, and they have given here constant pressure. If they say diatomic, then here you will put 7R by 2. Diatomic, then 7R by 2 you will put, okay. And then we can solve for the mono as well as di. Probably they will ask for the mono. They have asked previously also for the mono, okay. Done. So here in this one we got the work also, we got graph also here, we got this. If any curve is given, like this is given, like this triangle is given, we have to just find the area of the triangle, you know, half base into height, area of the rectangle, you know, length into width. Triangle, rectangle will be only given to you, and remember area of only PV graph gives you work. Then we can say this graph is important here, and here we got in this one your Q for the different process different, but delta U is same for all. Work is also different for different processes here. And this question in this one, now I'll just tell one more question. They will say a gas is expanded by 3 processes. Okay, so this is going from V to 2V, and 3 processes are there. Okay, so now we can say here volume is given 3 processes. So first of all, you need to identify this one, you know, isobaric, this one is the isothermal, and this will be 100% adiabatic, because adiabatic is having more slope. Here if you release the ball will be becoming very fast in this one, like this. Here, okay. Now, so isothermal adiabatic you have to identify. They will ask where work is maximum. You can say work is always maximum in the where area is more. And where area is more, if you say in this one, then we can say in the your IB area is more, then your IT, and then your AD only this much area, IT some extra area, IB some more extra. So we can say W for IB, then we can write W for IT, and then we can write W for AD. Can you remember this thing? Then reverse question is coming. This is the question of expansion, and then they will ask the reverse. In the reverse, they will give you the same thing, that gas is compressed. So compressed means we are coming from okay, 2V to V. We can come like this, we can go like this, and then we can go like this. Here also you need to identify 3 are given. With isochoric not possible. This one is the isobaric. This one is, now these 2 you have to identify. If you release the ball, here ball will become very fast. Of course, this is the adiabatic, and this one is the your iso, okay, thermal. Now we can say work. Here area is less, here area is more, here maximum. So here we can say WAD, and then WIT, and then WIB. You can just remember reverse. If this one you remember, this is reverse. Okay. If this one you remember, this one is reverse. Okay, so for this one you remember or you don't remember, everything is reverse for this one. First one you have to remember, and first one is very easy to remember. Okay, so in the first law, these are some important things that you have to remember. I will go for the now your engine and refrigerator. Okay, so because this year we are feeling engine and refrigerator should be coming. Engine and refrigerator. Okay, add. So listen, before this one I can write here polytropic process also, because this is always hot in the recent year. So we can say polytropic is like this: PV power x is constant, and whenever they are given like this one is your polytropic process. For the polytropic process, you have to remember, okay, that first of all, molar heat capacity. Heat capacity is different for different process. So molar heat capacity for the polytropic is given by C equal to CV plus R by 1 minus X. Okay, what are the basically your X you have to figure out from here. PV power X. Like if I say PV square, you can easily say, sir, X is 2. If they say PV cube, you will say X is 3. Okay, so we can easily figure out this X, and then you will put here. Q is always given by N C delta T. C you will find from here. Okay, and delta U for any of the process in this world. Delta U for every one, each and every process is NCV delta T. So about the delta U, never do the mistake. Lot of people they will ask that delta U, ratio of delta U for the isochoric and isobaric. So for isochoric they write NCV delta T, isobaric they write NCP. Delta U for any of the process they are asking. It is always NCV delta T. Delta U is always same. Okay. Yes. Now, next thing I can say work. Work we can remember like this: NR delta T by 1 minus X. Okay, like adiabatic is PV power gamma. Adiabatic, if you say PV power gamma, and for PV power gamma, okay, work is basically NR delta T by 1 minus gamma. So same as it is we heard it, NR delta T by 1 minus X. NR delta T by 1 minus X. I will take one question on this polytropic here. So these are the only things that you have to remember in the polytropic. This thing, this, and this work is NR delta T by 1 minus X. C is basically CV plus R by 1 minus X. Q is NC delta T, and delta U is NCV delta T. Question is here, V proportional to T square. And they're asking find work. Okay, work they are asking for this process. Whenever you are not able to decide which process is this, 100% that process is your adiabatic, 100%. Okay, now we can say in this one V proportional to T square, but for the adiabatic we can solve the question only if we are having PV power X. So we have to convert this one into P and V. And how to convert this one into P and V? Actually, you can write for the P and okay V. We know PV equal to much your and RT. So now we can write here NR is constant. So T you can replace with the PV. So we can say V proportional to here P square V square. Now 1V and 1V you will cancel. So what we left here, P square into V equal to constant. 1V and 1V cancelled. I need P ln PV power. Power of P should be 1. Here power of P is 2. So we'll divide with 2. So it becomes, okay, here 2 and here 2. So 1 by 2 equal to constant. Now we can say that in this case, if you compare PV power X constant, X is half. And if X is half, then we can say work will be given by NR delta T divided by 1 minus X. So it becomes NR delta T divided by 1 minus 1 by 2. Because X is, if you compare, X is your half. Okay. So we can say 1 minus 1 by 2. So it will go upside 1 by 2. So it will be 2 NR delta T. Okay. Now, means if they have given any equations, we can figure out the same way. Okay. Yes. Now going for the your engine and refrigerator here. Add. In engine basically, okay, what you have to remember, the efficiency of engine is given by, first of all, work by Q1. Okay, work by Q1. Efficiency given by work by Q1 equal to, we can say, 1 minus Q2 by Q1 equal to, we can say, 1 minus T2 by T1. Okay. If you want percentage, then you can just multiply with the 100. Okay. If you want percentage, then you can multiply with the 100. Okay. So this is for engine. For engine. Okay. Carnot engine. Okay. Carnot. This is a reversible engine. Okay. Reversible engine has maximum efficiency, but not 100%. Maximum efficiency, okay, but not 100%. No engine can have, okay, remember this one. No engine can have 100% efficiency. It is not possible to make any engine which is having 100% efficiency. You cannot make any engine which is having 100% efficiency. Carnot is the reversible engine, has maximum efficiency. Reversible have efficiency more than the irreversible. Reversible engines have efficiency more than, okay, irreversible. Efficiency depends on temperature. Temperature. This is the temperature of, okay, sink, and this is the temperature of source. So it depends on temperature of source and sink, and always T1 is more than T2. T1 is more than T2. So these are the some theoretical things. No engine can have 100% efficiency. Carnot engine is the reversible, is having more efficiency, but not 100%. No engine can have 100%, and it depends on the temperature. So all engine cannot have same efficiency, because temperature will be ultimately different temperature, efficiency will be different. This is the formula for the engine. For refrigerator, if I say, first I'm writing the formula, then I will take the question. So for the refrigerator, we use the word COP. Efficiency we write with the eta. We write this one with the eta, okay? And here COP we will write with the beta. So this is given by, okay, COP is Q2 by W equal to, we can say, Q2 divided by W is always Q1 minus Q2 equal to T2 by T1 minus T2. So this is the formula of COP. Okay, COP. Always you have to remember COP. Okay, and COP cannot be infinite, because if you want to make it infinite, na, T1, T2 cannot be same. So COP infinite not possible. Like here I'm saying 100% not possible. So COP coefficient cannot be infinite. COP infinity not possible. Okay, infinity not possible means COP cannot be infinity. Okay, reason is because T1, T2 not same. Okay, relation you have to remember, eta equal to 1 divided by 1 plus, okay, 1 plus beta. This is the relation between, okay, your engine and COP, means refrigerator efficiency. They will say that if this engine is used as refrigerator, or this refrigerator is used as engine, then, okay, their efficiency they will ask. So this one you have to remember, the efficiency eta equal to 1 by 1 plus beta. So this much information if you remember in the engine and refrigerator, probably you will be able to do the questions. Now I will take numericals, what type of questions they will ask. But first of all, this thing you need to install in your mind some theoretical points. Okay, T2 sink, T1 source. T1 is always more than T2 everywhere. Okay, Carnot reversible have more efficiency than the irreversible. Carnot has the maximum but not 100. No engine can have 100%. Any refrigerator cannot have infinite COP, because T1, T2 not same, or work cannot be 0. Okay, and relation is eta equal to 1 by 1 plus beta. Yes. Now I'm taking the question. So I'm now taking the question here on this thing. They will say an engine, okay, having efficiency with efficiency 1 by 10 is used as refrigerator. Find COP. Engine with this efficiency is used as refrigerator. Find its COP. So directly we can say eta equal to 1 by 1 plus beta. Eta is 1 by 10, so 1 by 10 equal to 1 by 1 plus beta. So you can say, sir, 1 plus beta equal to 10. It means beta equal to how much here? 9. Over. Can we figure out these questions? Eta given, beta we can find, beta given, eta we can find. This type of question. Engine with efficiency 1/10 is used as a refrigerator. Reverse question of this will be that they will give you the refrigerator COP, then we have to solve. Okay? First type of question. Now, second type of question that I will take here in this one is on the refrigerator. They will say that a refrigerator is working between -3 degrees Celsius and 27 degrees Celsius. Power used is 10 watt. Power used is 10 watt. Okay, it is using 10 watt power. Okay, they have given in this one. Find energy, find heat. Okay, heat delivered to surrounding. Heat delivered to surrounding. In the refrigerator, you need to remember it takes energy, Q2 energy from the lower temperature by doing work W, and the total energy Q1 it will throw outside. In the refrigerator and AC, same principle we are using. It takes energy like AC is there. So it will take energy from this room and it will throw total energy outside. So basically in this one, we can write, first of all, we have to find your COP. So COP is given by T2 by T1 minus T2, which is basically, Q2 divided by W, So T2 we can find, because if you have to find the Q1, so you can say Q1 will be equal to basically W plus Q2. They are saying per second. Per second we can say, so in 1 second, how much work will be there? 10. So work already we know that is the 10 per second. Q2 I have to figure out. They are saying how much energy I will reject, how much energy I will deliver in the surrounding. So how much energy I will deliver in the surrounding, that energy is basically Q1. Q1 I will throw in the surrounding. So we can say W work I am doing, and who will be doing this work? W, basically your compressor, and that what is the power consumed by that compressor? The 10 watts. So per second we can say your 10 joule will be there, because watt is nothing but the joule per second. Okay, so we can say this is the 10. Q2 we have to find. So T2 I can put, or how to put in the Kelvin. So this will be 270 divided by T1 minus T2. If you take the difference, that is a 30 equal to Q2. Work is here 10. So now we can say this becomes here 9. Q2 is 90. And once you got Q2 is 90, so I can put here Q2 as 90. So my answer becomes 100 joule per second. It will throw outside. It is having capability to throw 100 joule per second outside. I hope this question is clear. Yes. Any problem in this one? Okay, now I'll take next question. Generally, they will ask question of COP, but I have added one term extra that you should know that how much energy is rejected to the surrounding. Q2 it takes from the lower temperature and reject Q1 to the surrounding. Okay. So now we'll take next question on the engine here. They will say an engine operates between 27 degrees Celsius and 327 degrees Celsius. 27 degrees Celsius and 327 degrees Celsius. It performs 5 into 10 power 2 joule work. This much work it performs. Find energy rejected into sink. Energy rejected into sink is asked. If you read this one, 27 and 327. This is also similar question, previous one. Just little bit changes I am making in the previous question. Then with the refrigerator, this is the engine here. They are saying in this one that 27 and 327. It is doing this much work. Find energy rejected into sink. In engine, basically what happens, it takes Q1 energy, then it performs work, and then remaining energy it is sending into your sink. Remaining is sending into sink. So you have to find the Q2 here. And you can say, sir, Q1 will be equal to W plus Q2. So I can easily figure out Q2, which will be Q1 minus W. Here W is given, Q1 is not given. So your target is to find the Q1 first. Okay, in this one, W is given, Q1 you have to find. So what we can take here, we'll use the formula efficiency equal to 1 minus, okay, 1 minus T2 by T1 equal to, we can say, W by Q1, okay, because work is given. So how only this math, okay, this option is only left with me, that I have to use 1 minus T2 by T1 equal to W by Q1. W is given, okay. So let's put the values. 1 minus T2, T2 is always lower temperature, so 300 divided by higher temperature 327, which is equal to the 600 Kelvin. This one is the 300 Kelvin. So I can put here 600 equal to W is your 5 into 10 power 2 divided by, we can say, Q1. So 1 minus 300, 600, 1 by 2. So here 1 by 2 is coming, 1 minus 1 by 2. So it becomes actually 5 into 10 power 2 divided by Q1. So Q1 we can say becomes 5 into 2, that is the 10 into 10 power 2. So 10 into 10 power 2. So now we can put here, this is the, okay, 10 into 10 power 2 minus 5 into 10 power 2. Answer becomes 5 into 10 power 2. Okay, this is basically your, okay. I hope this question is clear. Yes. Now we'll take another question that I'm feeling it can be asked this time. The percentage based efficiency. Okay, percentage based efficiency. So next question going to take add. They will say efficiency of an engine is 40%, okay, if when temperature of okay, source is 227 degree Celsius. Temperature of source is 227 degrees Celsius. They're saying keeping temperature of sink constant, okay, sink constant, find change in temperature of source to get 50% efficiency, to get 50% efficiency. This question is having two parts. One part is efficiency of engine is 40% when temperature of source is 227 degrees Celsius, and keeping temperature of sink constant, then find change in temperature of. So now we can say we'll solve in the two way. First, it is the 40%. So we can write 1 minus T2 divided by T1 into 100 is basically your 40. And here they have given the temperature of source is 227 with the 500. 0 cancelled. So I can say here this will be 2, this will be the 5. So 1 minus T2 by T1 equal to, okay, 2 by 5. So from here I can say T2 by T1 equal to, okay, here how much? 1 minus 2 by 5 means 3 by 5. And T1 I can put, T1, that is the source, which is given how much? Your 227. So 227 and T1. So 227 means your 500 equal to, I can say, 3 by 5. 5 and this is 100. So you can say here T2 becomes 300 Kelvin. And if you read this second line, this type of question they have not asked previously. We are feeling that it can be asked. Last 3 years also they have not asked. Keeping temperature of sink constant means this one we have to make the constant. This one I have to make, no, I will not change. Change we have to do in the source. And we need 50%. So same thing we will do whatever we have done here. One more time, 1 minus T2 by T1 dash I can write, because T1 I am changing, into 100, and now efficiency is 50. So 0 cancel, this becomes 5 by 10, which is the half. Okay. So 1 minus T2 by T1 dash becomes here how much? Your half. So T2 by T1 dash becomes here how much? Your half. If you see T2 is basically 300 divided by T1 dash equal to half. So we can say T1 dash becomes how much? Your 600 Kelvin. So earlier which was the 500 Kelvin, now 600 Kelvin. Now 600 Kelvin. So we can say how much change? Change required is 100 K. Okay. In this one, if you say here, again, I will tell this question important. So again, I am saying, because this coming, it will not be considered as very easy question. It will not be very easy one. Okay, so listen. Earlier, it is given efficiency of engine is 40% when temperature of source is 227. So I can see here 1 minus T2 by T1 into 100 equal to 40. So cancel. So here we can write, okay, 0, 0. So this will be using 2, 2. Here 5. So 2 by 5. So T2 by T1 equal to your 1 minus 2 by 5, 3 by 5. T1 is your 227, which is the 500. So 500, 5, this 300. Okay. So T2 we got 300. Then this one we have to keep constant, keeping temperature of sink constant, find change in temperature of source. So 1 minus T2 by T1 dash into 100 equal to 50. Again 0, 0 cancels 1 by 2. So T2 by T1 dash is half. So 300 by T1 dash is basically your half. So here T1 dash is how much? Your 600 Kelvin. So delta T we got. Okay. Change we have to find. Earlier this was 500 Kelvin. This was the 500 K and now it is the 600 K. So change it the 100 Kelvin or 100 degree Celsius. Yes. Can we do this pattern if this pattern is asked in the examination? Okay. Now. Okay, so I think now for 10-minute break. 10-minute break, you can finish out your okay, whatever things you have to 10 or 15 minutes. Okay. We'll start again at 10:05. Means 9:05. We'll start at 9:05. Okay, and 9:05 to 10:15. Okay, so we'll be having effectively 1 hour 10 minutes. Okay, okay. So now go fast and okay, have your breakfast and all the things. We'll meet in the next 10 minutes. Try to come in the 10 minutes. Okay. But 15 minutes is the break time. Sharp 9:05 will start. 9:05. Okay. We'll start. Go fast. Yes, I will share the QR at the last. Now go and okay. Come at 9:05 sharp. back again. Now it's break time is over. So I hope breakfast was done. All have completed. Okay, so now we have gravitation, because gravitation is generally two questions they ask. So in gravitation, whatever the focus area, important areas are there, then we'll go for the oscillation, then wave, and at the last we'll go for the fluid. Okay, one thermal part which was the important. Okay, we have done all the whatever things I was feeling that can we ask was completed. Can we start now? Yes. See, the gravitation, first of all, that you have to do is the variation of G. Okay, this is the one segment they ask a lot of time, variation of G. Okay, now G will be varied with the height as well as depth as well as due to rotation, but most important is the height and depth. Okay, so with the height, first I will write the formula. G with the height is basically G divided by 1 plus h by r whole square. This is the formula with height. Okay, means for the height, this is the formula. Okay, with height. Okay, with height. So this is the formula. If h is less than r, if h is very less, then this formula will become your G 1 minus 2h by r. But mostly we have to use this one. Okay, this formula G h equal to G by 1 plus h by r whole square. If h is less than r, for the small height we will use this one. Okay, now with depth, if I say, then we can say, okay, means with depth here. So with depth we can write, there is only single formula, that G with the depth is given by G 1 minus d by r. Okay, this is a single formula here, either a small, either your large, it is the same thing here. Okay, if I say percentage change, sometimes percentage change is also coming, so we can say percentage change here will be given by, means percentage change means change delta G divided by G into 100. So you can say here change, if you find, here change is just 2h by r. So we can say change of 2h by r is there. So percentage we carry 2h by r into 100. Okay, this is height. Okay, this side height thing is over. Okay, height, this first formula, then second 1 minus 2h by r, and then percentage change is given by your 2h by r into 100. Yes. Now here we can see percentage change, if you have to do, then here percentage change is given by delta G by G into 100 is actually equal to d by r into 100. Okay, this is the d by r into 100. With the rotation also variation is there, but that doesn't matter, just I'm writing the formula. G dash equal to, we can write G minus r omega square cos square lambda. But last one, just you have to keep the formula in your mind. Numericals are coming on these two things. So I will discuss first one and second one. Okay, yes. Anyone having problem in this one? And you, most importantly, you have to remember the G. What is the G? A lot of people don't know what is the G. G is basically equal to Gm by r square. Mass I can write as, okay, volume into density. So you can write this thing as G. Volume will be here 4 by 3 pi r cube into rho divided by r square. So we can say in this one r square r cube. So G will be equal to this one 4 by 3 pi r rho G. Okay, so if they say this thing, okay, everything about the G you have to remember here, Gm by r square. G, mass is the volume into density. If they say two planets having same density, two planets of the same density, then we can say G is proportional to how much your, if they give same mass, if they have given same mass, so same mass, then you will write G as 1 by r square. G proportional to 1 by r square. Okay, if they have given the same mass, G proportional to 1 by r square, you will use this one. Okay, capital G will be constant, mass is same, so proportional to 1 by r square. If they say same density, and if same density word is given, then we will write G proportional to how much your, here in this one 4 by 3, everything is constant, density same, G same, so G proportional to R. So you have to read what is given. G is okay, they have given the same density or they have given the same mass, so G proportional to 1 by R square as well as R. Okay, So all the important formula are written on this slide here. Now I will take the numericals, okay, on each. Here question is very simple. Two planets having same density, having radius 2r and 3r. What the ratio of G? We can write G1 by G2 will be equal to much here? R1 by R2. Okay. So mainly questions on this thing. They will ask for the same change in the height as well as depth. If you want same change, means if you want change same, here change is 2h by r, here change is how much? Your d by r. If you want change same, then they will ask what are the relation of depth and height. So we'll write here for same change, okay, for same change, if you say change here is 2h by r and their change is how much? Your d by r cancels, so we can say for same change always you remember this is the formula 2h equal to d or d equal to 2h for the same change. Okay, so 2h equal to d, this thing you have to remember. Means theoretically these are the theoretical things. Now next comes numerical. We will say weight of a person is 640 Newton at surface of earth. Find weight at a depth 3r by 4. Depth at 3r by 4, they are asking the weight, your weight. So we can say G, D we can write here in this one, G 1 minus d by r. If you multiply here m and here also m, this becomes the weight at the surface, this becomes weight at the depth, and weight at the depth how to find. So we can say WD will be equal, mg is in this case is how much? Your 640. We get 1 minus d. D is your 3r by 4 into r cancelled. So 3 by 4, 1 by 4. So 640 into 1 by 4, which becomes how much here? 160 Newton. Okay. So I hope this type of questions, if they are asking, we can do. Next will be the vice versa question. They will give you the weight. They will ask what is the depth. Weight will be given and depth will be asked. Okay. So that also we can do. Okay. Now, next question I will take on the height. They will ask question on height here. So they will give you weight at surface of earth h w. Find weight at height r by 2. Weight at height r by 2 you have to find. What is the weight? Of course we know G decreases both upside also as well as downside. G is always maximum at the surface. Maximum at the surface. Upside you go or downside you go, G will decrease. So we can say formula for the height is GH equal to G divided by 1 plus H by R whole square. If I multiply here M and here M, this becomes weight at the surface. This is the weight at height. So WH will be given by W divided by 1 plus height is here R by 2. So 1 plus R by 2 into R whole square. R cancelled. So we can say this becomes W divided by 1 plus 1 by 2 whole square. 1 plus 1 by 2 is 3 by 2. Okay. So you will get here 3 by 2 whole square will be how much here? Yes, 9 by 4. So this becomes 4W by 9. Okay. I hope this question is also clear. Yes. Okay. Variation of G with the height, with the depth, always important. I hope you will be able to do if anyone is asking question on this thing. Okay. And remember this point, a lot of people do mistakes in this one. G, okay. If mass same, then G proportional to 1 by R square. If same density, then G proportional to R. Now, next thing, important thing is in this one is your, okay, escape velocity. Before escape velocity, I will take one hypothetical model question. They will say generally your gravitational force is proportional to 1 by R square. But they will say if force is proportional to, okay, inversely proportional to 1 by R power n. Force is varying as like this. Force proportional to r power n. N can be anything. N can be 2, n can be 3, n can be 4, n can be 5, anything. So force is proportional to 1 by r power n. This is given, okay? 1 by r power n. They will ask what will be the time period, what will be your some other variables they will ask. So in these questions, what you have to do, f proportional to 1 by r power n, whenever you get, okay? They will give r square, r cube, r power 4. Method is same. You can just mug up this process that we have to follow. We can write f should be equal to k. K is some constant, okay? And you know force, whenever circular motion is there, okay, then we can write it should be equal to mv square. If they are asking suppose time period, then better to write mr omega square, okay? Mr omega square, okay? Now, what we can write here, k is constant, mass is constant, so we can write omega square will be proportional to r and will be added here, so 1 by r power n, okay, and 1 r, so it will be the r power n plus 1. If you multiply the r and n, it becomes r power n plus 1, okay? Omega square is this, but you know omega is how much your? Omega is 2 pi by t. If I say here, omega is basically your 2 pi by t. Is omega is proportional to what's your 1 by t. Omega is, because 2 pi is constant, okay? So if omega is 1 by t, then I can write here in this one omega square as 1 by t square proportional to 1 by r power n plus 1. So from here I can say t, okay, is square proportional to r power n plus 1. So t proportional to r power n plus 1 divided by 2. This is common in the Bohr model also. Same question in Bohr model also comes. Okay, so you have to, n can be anything, n can be 1, 2, 3, 4, 5. So f proportional to 1 by r power n. So f equal to k r power n here equal to mr omega square. This is the only single step. This step only you have to remember that, okay, whatever the force is given equal to mr omega square m and k constants, we can say r will be down. So it will be how much your r power n plus 1, and then we can write omega is 2 pi by t. So we can write here omega proportional to 1 by t. So omega square will be 1 by t square. 1 by t square is proportional to 1 by r power n plus 1. So t square r n plus 1. This will be going downside. Clear? Okay. Remember this thing. Okay. It is coming in the Bohr model also. So f, whenever anything is given equal to mr omega square, you have to put, you will get the answer here. Okay. Now we'll take escape velocity. Escape velocity, first of all, formula you have to remember. Escape velocity is the velocity, minimum velocity given so that it will escape, it will go to the infinity. Minimum velocity so that it, okay, goes to infinity. And formula for this one is v equal to, first I'm writing all the formula here, 2gm by r. It can be written as 2gr. It can be written as, I can write in terms of mass, okay, here volume by, okay, volume into density. So just see one time 2g. Suppose if you forget, then I'm putting here mass 4 by 3 pi r cube into rho divided by r. So this one you can write, okay, in this one 8, okay, pi r square, okay, r square, okay, rho g, okay. Now 8 pi by 3 r square rho g. Suppose if you forget, then you can easily figure out mass. We can always write volume into density 4 by 3 pi r cube into rho. Lot of people only remember this formula, only this, and they ask question from here, and they have asked also previously. So mass, volume into density, so 4 by 3 pi r cube into rho divided by r, we got 8 pi by 3 r square rho g, okay. Now we can say that if, okay, I'm writing only first theoretical things, okay, then numerical. If mass constant, then we can say, okay, VE proportional to much your mass constant or mass same, okay, two planet having same mass, then we can say VE proportional to 1 by root r. You can see here mass constant, mass same, two planet, they will ask the question like this, two planet, okay, having same mass, then ratio of escape velocity, ratio of V escape. Okay, this will be the question. Okay, like this. So we can see if mass is same, then V proportional to 1 by root R. But if I say if density is same, suppose they have given density same, like the in G also I told the same thing. If density is same, then I cannot use this thing. Here how to come? If density is same, then rho same, G same, 8 pi by 3 same. So here if you see, then the root R square, R will be coming outside. Okay, so you can say then V proportional to how much your R. Then you have to use this formula in this one, 8 pi by 3 constant, rho constant, G constant. So root R square means R. If they say that two planet, like I can say here question, okay, two planets having same density and radius of first is twice of other. Radius of first is twice of other. Then ratio of V escape. Ratio of V escape. Ratio of first is twice of others. You will use not 1 by root R. You have to use V proportional to R. Okay. So we can say VE1 divided by VE2 equal to, we can say, R1 by R2, and radius is, okay, first one is twice, so 2R by R. Answer becomes how much? Your 2 by 1. I hope this thing is clear. If mass is given, if mass same, and then, okay, we have to use V proportional to 1 by root R. If density is same, then we have to use V proportional to R. Okay, yes. Now, V escape, okay, does not depend, okay, does not depend on mass of projecting body. It will not depend on mass of projecting body. Okay, angle of mass of projecting body and angle of projection. How you project does not matter. Okay, how you project does not matter. It remains same. Okay, but it depends from where you are projecting. Whether you are projecting from the surface of Earth. This is basically, this formula is for the surface of Earth. If you project from somewhere else, then value will be different. Okay. One problem on same mass. Okay, one problem on same mass I will take here. They will say, here I will write in this one. They say V escape for Earth is 11.2 kilometer per second. Find V escape for a planet, okay, planet having same mass and radius R by 4. Radius is 1 by 4th, but mass is same. Okay, mass is same, but radius is how much? Your R by 4. Okay, can I take next slide for this one? For this question you can read just. Okay, mass is same, radius 1 by 4 means this is the Earth. This one is your Earth here, and this is the another one. Okay, its mass is m, but radius is r by 4, and here radius is r. Its escape is 11.2. This escape we have to find. So now we can see here mass is same. And if mass is same, then we can write how much? Your V1 by V2 will be equal to, okay, root of R2 by R1. R2 by R1, because here written, if you say that if mass is same, then V proportional to 1 by root R. Okay, 1 by root R. So I have to take the R2 by R1. Okay, so we can write here in this one that R2 by R1. So R2 is basically how much? Your R by 4 into R. So R cancels, so it becomes 1 by 2. V1 is how much? Your 11.2. So 11.2 by V2 equal to 1 by 2. So we can say V2 becomes 22.4. Okay, I hope this is clear. One planet, this is the Earth, having mass m, radius r, escape 11.2. Another planet having mass, same mass, but radius 1 by Okay, radius is your 1 by 4th. Then we have to find here mass is same, so we'll use V1 by V2 root of R2 by R1. Okay, so one question on the mass is over, and one question is there on this one. Okay, here density was same. Okay, here density was same, their mass was same. Okay, yes. What I was saying, escape velocity does not depend on angle of projection. You project at the 45-degree or you project at the 60-degree, it remain same. Okay, it will be same either 45-degree or 60-degree, but it depends on your height from where you are projecting. Like if I say, if I project from the surface of earth, if from the surface of earth, then this V is how much? Your V escape is root of 2 gm by r. Okay, 2 gm by r. They are giving one question here that if a particle is projected from height h equal to 4r, height h equal to 4r. One last slide is here. I will send this slide. Okay, I will share the QR code, then you can, okay, you can get these things. So particle is projected from height h equal to 2r. Escape velocity will be same or different. First of all, they will ask theoretical question to us, that what will the escape velocity? We know it will be different. Okay, how to solve this one? You will see we are not projecting from here, we are projecting from here. This is your point of projection from here. So ultimately here you have to derive. Okay, so this question becomes a little bit higher side for the average people. So listen here what I'm going to do. Just we have to derive here. I will write potential plus kinetic here, and at the infinity, potential and kinetic both are 0. Okay, so let me write here potential. So potential at this point of projection, this is the point of projection here. Okay, point of projection. So minus of g mm divided by, okay, r plus h, because distance we take always from the center. So r plus h. Okay, so I can say r plus 4r will be 5 by r plus kinetic here how much? Half mve square. Okay, equal to 0 plus 0. So now I can say here in this one, a small m will be cancelled. So you can say, sir, v will be equal to, if you say here I can write, okay, that will be going that side. So it will be v square equal to, I can say, so 2 gm divided by how much? 2 gm divided by how much? Your 5 r. Okay, now we can say, if I say in this one v, so v we can say becomes okay here root of 2 gm by 5 r. It means how much? Your 1 by root 5 into root of 2 gm by r, and this is what your v escape. So it becomes your ve by 5 r are taken because height is 4r, na? So 4r plus r, 4r plus r is 5r. Okay, 4r plus r 5r, so 5r, and then this is the 5r root 5. So answer becomes how much? Your ve by root 5. Okay, so if you project from some height, can you find like this? Very easy calculation. You have to just write your potential energy. If I say h equal to 2r, then what you will put here? 3r. Here 3, and here also will be 3 and 3. Okay, so you project from anywhere, we can find your escape velocity. Okay, here suppose this is the 7r, then what you will put here? 8r. Here also what's your 8r, and here also your 8r outside. So 8 root 8 outside means 2 root 2 will be there. Okay, which this equation you have to write. Okay, then we can easily solve this thing. Now next point I will take in the escape. If particle, okay, if particle projected with more than v escape, means velocity of okay, projection is more than v escape. Like they have given here, vp is k times of v escape. Okay, but k is more than 1. K more than 1 means velocity of projection is more. And if velocity of projection is more, when it will reach infinity, then it will be having some energy left. So it will be having some kinetic energy. In that case, velocity at infinity is given by, okay, root of k square minus 1 into ve. I will take numerical, but first you have to remember this. You have to mug up this formula first, okay? If you are projecting a particle with more than v escape, then at escape, at the infinity, it will not stop. It will be moving. With what velocity it will be moving? That is given by root of k square minus 1 into your VE, okay? Here I will write if particle projected with less than v escape, okay, then it will reach some maximum height. It will reach maximum height. Means it will not reach infinity, it will reach some maximum height. If you are projecting with lesser than v escape, it will never reach the infinity, it will reach some maximum height. And in that case, that maximum height is given by h equal to k square r by 1 minus k square, okay? This is your maximum height. Here also Vp is basically k times of v, but here k is less than 1, okay? So direct formula also can be asked. They have asked previously formula in 21 when paper was tough. This formula was only asked. A lot of people have not done, or they can ask numerical also based on this. So I will take numerical as well as formula. You have to remember only two cases are there, either more than v escape, either less than v escape. Both are written in front of you. This is for more than v escape, this side for less than v escape, okay? Less than v escape, it will never reach the infinity, it will reach the maximum height. So now I will take the question. So this formula is over, root of k square minus 1v, and this is the k square r by 1 minus k square. Question will be like this. A particle, okay, Vp is half of v escape. A particle is projected with half of v escape. If particle is projected with half of v escape, it will never reach infinity. So we can say it will reach some height. Here k value is how much? Your half. And if k is half, then we can say h equal to k square r by 1 minus k square. So we can say k square will be how much? Your 1 by 4 r divided by 1 minus 1 by 4. So you can say, sir, this is the 1 by 4 r, and here it will be how much? 3 by 4. So cancel. Answer becomes r by 3. I hope this is clear. They will say the question, a particle projected with half of v escape, half of the v escape means k is half. So we can say k square r by 1 minus k square, and calculation is over, okay? Now, next question I will take more than v escape, okay? More than v escape. So I will take the next slide here. They will say Vp equal to 2 times of v escape. A particle is projected with twice of escape. Twice of escape, double of escape. So double of escape, then we can say, of course, it will reach infinity. Here k is 2, it will reach infinity, na? More than v escape, of course, it will reach infinity. If lesser than v escape, then it will not reach infinity. More than v escape, it will reach, okay? So here it will reach. In the previous question, it was less than v escape. That's why it will not reach infinity. So we use this formula, k square by 1 minus k square for the maximum height. And here it will reach. So we can say v infinity is given by how much? Your root of k square minus 1 into ve. So we can just put here root of k. 2 square is 4 minus 1 into ve. So we can say how much? Your root 3v. v you can put root 3 into root 2 gm by r. So this finally becomes root of 6 gm by r. Okay? Yes? Clear? Okay. Escape is over here. Escape velocity is over. In escape velocity from the starting, if I say whatever thing I have told you, okay, in this one, these are the 5-6 things. First, I told you formula here in this one. That are the, okay, very important formula for the escape. This is your 2gm by 2gr. And then in terms of your density also, mass same, v proportional to 1 by root r, density same, then v proportional to r. And then to question all this thing. And okay, we got here basically this question, same mass was given. So we have used root, okay, 1 by root r. And then here, okay, if you project from, it will not depend on angle of projection. If you project in the 45 degree or 60 degree, it will be same. But if you project from some height, it will not be same. So we have to write your potential energy plus kinetic energy equal to 0 plus 0 at the infinity. And then we got, okay, escape from any point we can calculate. And then this is the basically more than escape, less than escape, okay? Now, then comes energy of the satellite. So for this one, you have to remember, Potential energy is always given by minus of G, okay, m by R, okay, minus of G by, I can write here capital R in small r, and kinetic energy is always given by G by 2R. If you add both, then total energy is given by minus of G divided by how much here? 2R. Okay. First of all, formula you have to remember, graph you have to remember. Graph, this is the graph of kinetic energy. Kinetic energy is always positive. This is the graph of potential energy, and total energy will be summation of both. So it will be in the middle but negative. So this dot dot is for total energy. Okay. So you have to remember these three graphs: kinetic energy, total energy, and potential energy. They will ask one question. In the previous examination also it was asked, that is the important question. Is satellite, okay, how much energy is required to shift satellite from this orbit to this orbit? Energy required to move satellite from this orbit to this orbit. Okay, like previous exam question, if you remember, but right here, energy required to move satellite from orbit of radius R1 to R2. Okay, they are saying how much energy is required. Satellite is moving body, and if satellite is moving body, then satellite will be having kinetic energy also as well as potential also. So kinetic and potential both are there in the satellite. So when you have to calculate the energy, will you take will you consider only potential, will you take only kinetic, or you will take both? Satellite is having both energy. When you are changing the orbit of this one, both energy will be changed. So we are going to consider both energy means total energy. So always in these question of satellite, mug up now, that work will be equal to difference of total final minus total initial. Okay, remember this thing. In case of satellite, okay, total means both we have to take. So total final minus total initial, both we need to take. Okay, so total you have to take. This is the rule for you. Okay, you can make this rule. Okay, don't use extra brain. Okay, sometimes extra brain is creating a lot of problems. So this is the, okay, T final I can say minus of G divided by how much your 2R2. Okay, 2 is there in the total, minus minus is plus, G divided by how much your 2R1, and then you can take the, okay, so G divided by your 2 outside, answer becomes 1 by R1 minus 1 by R2. I hope this is clear. This question, yes, okay. Can we do R1, R2 can be anything. R1 is, okay, R1 will be always R plus H1. Suppose they have given the height now, and R2 will be how much your R plus H2. Suppose height is given. They are saying satellite is at this height. You have to shift this satellite from height 2R to 3R. So you know that, okay, what radius you will take? R1 you will take R plus H1, and R2 you will take R plus H2. Means distance is always taken from center. Okay, if suppose they have given the height is given, okay, like this is the your, okay, Earth, satellite is here at this height. Okay, so if this height is H1, so we know its orbit will be basically always from center R plus H1 and then R plus H2. Okay, and this is the only formula that we have to use here. Can we do this thing? If this also you mug up, just you can put the values here over. Now, then I will go for next thing, that the means in the gravitation things are done. Hypothetical model also I have told, and your escape variation also we have done, and this is, okay, satellite energy done. Now we'll go for the next one, that is your oscillation. Okay, in oscillation you need to remember first of all, okay, your spring system. Okay, spring system is 2 pi root of m by k. Okay, 2 pi root of m by k, like this is there. So for this one, t equal to 2 pi root of m by k. First thing, okay. Second, in series, if I connect the spring, series means like this, one here and one here. Okay, in series, if I connect, then k equivalent is 1 by k equivalent is 1 by k1 plus 1 by k2. Okay, 1 by k1 plus 1 by k2. And if parallel, okay, parallel is actually like this. Parallel is always this way. Okay, like this one is your parallel. Okay, and this is also the parallel when okay, mass is in the middle. This is also the parallel. Okay, And when parallel, then K equivalent is given by K1 plus K2. I will not ask why it is parallel. You have to remember, okay, this is series. Okay, series will be exactly visible to you. When mass in the middle, then this is the parallel. Okay, and here parallel K1 plus K2. Okay, like if I say this is the 2K and this is the 3K, then what will be the K equivalent? You can say, sir, K equivalent in this case will be 5K. And if you write the time period for this one, then what you will write the time period? Because for this one time period, I can write T equal to 2 pi root of m by 5K. Okay, this is the parallel 2K, 3K. So T equal to 2 pi root of m by 5K. Okay, this is the 2K, this is the 3K. Then also answer is same. Okay, now here I can say T square is proportional to 1 by K. If I do the square, then 2 pi mass will be constant, so proportional to 1 by K. So in place of this one, 1 by K1 I can write T1 square. Here I can write T2 square. And here I can write your T equivalent square. So you got here T equivalent in this case is given by root of T1 square plus T2 square. Means this relation you have to remember for the K as well as for the T also you have to, okay, remember you have to mug up this one. K also as well as T. It is very simple to derive also. 1 by K, 1 by K1 plus 1 by K2. But we know T square is 1 by K. So in 1 by K1 I have written T1 square. 1 by K2 I have written T2 square. So this becomes your root of T1 square plus T2 square. Okay. Same thing here we can write T square is 1 by K. So K will be how much? Your 1 by T square. So you can write in the parallel basically here. We can write 1 by T1 square plus 1 by T2 square. And here we can write 1 by T equivalent square. So for the K you have to remember, and for the time period also you have to remember. So this is the, okay, series parallel things written here. If any problem is there, you can ask fast. Okay, and these are always important, these relations. Okay, this is always important, series parallel. These type of questions are very easy. I will take one question on the combination, series also as well as parallel also. And then, okay, I will take one question on this also. T proportional to mass, T proportional to root m. So one question on this, one question on the series and parallel, and this thing in the spring. That's it. So first I am taking here question on combination. They will give you like this. This is K, this is 2K, and this is 3K, and this is the mass. They're asking what is the time period of this system. Okay, time period they're asking. So we can say these two are in the parallel. These two are in the parallel. If these two are in the parallel, so these two we can simplify how? 2K and K becomes how much? Your 3K. 2K and K becomes your 3K. Yes. And again, this is your 3K and this is the M. Okay. Again, 2K, K is the parallel. So this becomes 3K. Okay. K1 plus K2 in the parallel, and then 3K, 3K. So we can use now for the series 1 by K equivalent will be 1 by 3K plus 1 by 3K. So you can say, sir, it becomes 2 by 3K. And now we can write K equivalent is how much? 3K by 2. So time period becomes 2 pi root of m by K equivalent. So you can say 2 pi root of m by 3K by 2. That will go upside. This is your answer. Can you do any question on this thing? Make sure that, okay, if some combination is given, some series, some parallel, they can make 2, 3, 4, 5 like this. Some of the series, some of the parallel can be combined series and parallel. For the parallel K1 plus K2, and for the series 1 by K1 plus 1 by K2. Okay, and this is the last, okay, last time we are doing the things. So make sure that I can do, because now no chance after this. Okay, whatever things I'm telling, if you are getting very good, otherwise mug up the process that this way how to do the things. That's it. If it comes, then okay, same way. This is just matter of 20 days. For 20 days you can just okay, keep here. After that, okay, throw anywhere, doesn't matter. Same principles, same thing coming. Okay, we can identify, we can do here. Okay, now I will take next question on the mass. They will say that in this one, okay? And here, either they can say like this is like 5 kg and this is your, okay, they can say 4 kg. And or they can say this is the 4 kg, this is the 5 kg, okay? Or they can put like this also, the same question, that this is the your 4 kg and this is the 5 kg, okay? They are saying time period of this system, either this one and this one, both are same question, okay? Time period is 5 seconds when both are attached. When both are attached, 5 seconds. If 5 kg mass removed, 5 kg mass removed, find new time period. New time period. What is the new time period if 5 kg is removed? So you can say T1 by T2 is basically given by root of M1 by M2. Okay, T1 by T2 is the root of M1 by M2. Now I can write, earlier this was the 5, so 5 by T2 equal to root of M1. M1 is how much your? Earlier both were there, so 5 plus 4, earlier 9 was there. Later on 5 is removed. If 5 is removed, then what is left? Only 4 is left. Only 4 will be oscillating. Initially both are oscillating. Later on 5 removed, only 4 will oscillate. So we'll write here. Then we can, this becomes how much your? 3 by 2. So you can say, sir, T2 becomes in this case 5 into 2, 10 by 3. I hope this is also clear. Okay, because now spring is over. I will take some of the questions on the your formula based questions on the energy velocity. So add. Listen, velocity is given by omega root of a square minus x square. You have to remember this thing, okay? Omega a square minus x square. I can say acceleration equal to minus omega square x. You have to remember, potential energy is always half kx square, and total energy, kinetic energy is half k a square minus x square, and total energy is half k a square. I hope these formula are clear to all. If not clear, you have to mug up now, okay? Now only. Don't say that I will do after the class. Now only, okay? V equal to omega root of a square minus x square, acceleration minus omega square x, potential energy half k x square, kinetic energy half k square minus x square, total energy, okay? They can say here in this one, this is the your half k square. They will say sometimes, suppose potential energy is, they will represent with U. They are saying potential energy is U, kinetic energy is K. What is the ratio of U? Okay, what is the ratio of K by U? What is the K by U? So we can say K by U will be how much your? K by U, you can put here half K a square minus x square divided by, we can how much your? Half K x square, half K cancelled. So answer becomes how much your? A square minus x square by x square. Can you do question like this? Ratio based. First question. Now, second one, they will say, at what displacement, okay, displacement, kinetic or potential, kinetic is, okay, 50%, 25%, kinetic is 25% of total. This is the question. At what displacement, kinetic energy is 25% of total. They can say total means they can say 25%, they can say 50% or 75%. 1 by 4, they can say 3 by 4, they can say half, they can say like this. Some relation will be there. We'll write kinetic equal to 25% means 25 divided by 100 of total. Can we put like this? As per the question, they are saying K equal to 25 by 100 into T. Now I will put kinetic formula. Kinetic formula is here, half K. So I'll put here half K a square minus x square equal to, I can say 25 by 100 is 1 by 4. And this total energy formula is half K square. So half K a square. Half K I can cancel here. So now you can say now how to simplify this. So 4 you can write here in this one. So 4a square minus 4x square equal to a square. So we can take 4x square equal to how much? 4x square equal to how much your? 3a square. Okay. So now we can say x will be how much your? X in this case we can say, okay, so we can write x will be equal to how much your? Root 3 by 2a. Root 3 by 2a is basically your okay, displacement. Yes. And from this displacement we can find the time also, because root 3 by 2, you know, it is a 60 degree. 60 degree na? 60 degree is pi by 3, so pi by 3 means time will be t by 6. But can we solve for the displacement first of all? Okay. Now, they are asking here, add x, v and a. Means I can say here x, v, a. Phase difference here pi by 2, here pi by 2, and here phase difference is pi. It should be remembered by everyone that x, v, pi by 2, v, a, pi by 2, x and a is pi. Okay. X, v, pi by 2, v, a, pi by 2. This x and a is, okay, pi here. You have to remember. Okay. Next thing that you have to remember, x, v, a. Okay. All have frequency. How much? And what is the frequency of x, v, and a? And x, v, a as well as force also. Okay. How frequency n? Kinetic energy and potential energy have frequency 2n. If this is okay, they have frequency n. All have frequency. Displacement, velocity, acceleration as well as force, they have frequency n. Then kinetic energy and potential energy have frequency 2n. This thing also you have to remember. I hope you can mug up. Yes. Okay. And in damp oscillation, simple questions you will do. Okay. Like it becomes 1/3. Okay. Like in okay. Suppose if I say starting from a naught in 10 minutes, it becomes 1/3. So we can write a naught by 3. Next 10 minutes, a naught by 9. Next 10 minutes, a naught by 27. They will ask in half an hour completed. Only these type of questions you can practice in the damped, nothing much. Okay. 10 minutes, a naught by 3. Next 10 minutes, a naught by 9. Next 10 minutes, a naught by 27. Okay. But these things, whatever, x, v, a, f frequency, and then k and p, mug up this thing. K and p have frequency double 2n. Okay. 2n. Okay. And then this phase difference relation. Okay. X, v, pi by 2. V, a, pi by 2. And then x, a, pi. And then these type of questions based on the formula. Based on formula only. Not detailed question. Okay. Formula based questions rest. Okay. Now I'll go for the your wave here. In the wave, first is the Doppler and then in the organ pipe. Okay. So for the organ pipe, I will not explain any theoretical points. I will directly do the numericals. And for the Doppler, I have to write the formula. And this is basically n v plus minus vo divided by v plus minus vs. This is the single formula in the Doppler. Okay. And some theoretical points. Doppler, okay, does not depend, okay, means apparent frequency does not depend, okay, apparent frequency does not depend on separation, does not depend on separation between source and observer. Means source and observer are at what distance does not matter. X and displacement, acceleration, pi, yes, okay, pi, okay, pi is written, x and a, pi, okay. Now this is the one, apparent frequency does not depend on separation between source and observer. It only depends on velocity of observer, velocity of sound, and okay, frequency. Separation will not depend. Whatever the separation is there, apparent frequency will not change. Okay, remember this point. Apparent frequency and s will only depend on n. It will depend on velocity, will not depend on the distance between source and observer. Okay, wavelength is affected or changed by motion of source. Means when source will move, then only wavelength will change. Okay, wavelength will change whenever source is moving. If source is not moving, then wavelength will change or will not change? If source is not moving, then wavelength will change or will not change? Yes. Yes. I also needed energy. So these 2 points you can remember. Now, here I will take 2, 3, 4 questions which are actually important. First one, they will say, a person is standing on platform, a train is coming, okay, towards the platform. So you have to find, okay, ratio of the frequency before and after crossing, okay, ratio of the frequency before and after crossing. Here this one is there, it is approaching, okay. Now you have to remember in this formula, if they are approaching, so when approach is there, upper sign will be plus, lower sign will be minus, okay. Upper side plus, lower side minus when approach is there, okay. If they are approaching towards each other, upper side plus, lower side minus. If they are moving away, if recession is given, so for the recession, upper is minus, lower is plus, okay. So this thing you have to remember, recession means moving away, then upper minus, lower plus, and if approach is there, upper plus, lower minus. So this is the source, this is the observer, okay, and this is again source will cross. So here source is approaching, and if you say observer, VO is basically at the rest, so 0. So here in this case, in case of approach, frequency will be more. Frequency will be more. So here I can say in this case, N1 will be N, V plus VO is 0, divided by how much here? V minus Vs, upper side plus, lower side minus. So we can see here N1 becomes how much here? N, V divided by V minus Vs, and this side I can say when it will cross, it will is moving away, and moving away, then we can say N2 will be equal to N, V, upper side minus, so 0, VO is 0, divided by V, okay, plus Vs. So we can say N2 will be equal to here N, okay, V by V plus Vs. If they are asking these values, N1, N2, anyone, we can find. If they are asking ratio here, so we can say N1 by N2 will be equal to, in this one, and V will be cancelled. So if you divide here, we can say, sir, this becomes V plus Vs divided by V minus Vs. So can you do the ratio based question? Ratio of the frequency before and after. What are the question here they are asking in this one? Ratio of frequency before and after. Yes, this thing we can do. Okay, so this is the one important thing, before and after. If they're asking only this one, what are the ratio, frequency before, we can calculate this thing. If they're asking after, we can calculate this thing. They're asking ratio, we can do the ratio. Vs is the source velocity, okay, source velocity they will give you, we can use this thing, okay. Now next thing is, if wind velocity is given, if wind velocity is given, then you have to consider wind velocity also. Means speed of sound is how much your? Okay, speed of sound is, suppose your V. V is the speed of sound, and W is suppose speed of okay, your wind velocity. Okay, if okay, wind in direction of sound, wind in direction of sound, okay, then okay, velocity of sound, you have to take velocity of sound, will you, okay, how much you will add, you will take effective velocity V plus W, then effective velocity will take how much? V plus W. If in the okay direction of sound, then you will take V plus W. And if opposite to, okay, if wind, okay, opposite to sound, so if wind is opposite to sound, then what you will take? That effective velocity will take V minus W. Okay, so this thing you have to remember whenever they give the wind velocity. So like suppose your sound velocity is 330 and wind is moving in the same direction of sound, then you will add, opposite you will subtract. Okay, wind will be always given 10 or 20 something. And what is the direction of sound? Sound always start from source to observer. So if anywhere you are having doubt, you having confusion regarding the direction of sound, sound starts from source, moves towards the observer. Sound to observer, sound to, okay, sound is always source to observer. Sound is always source, it will start, it will go towards the observer. So sound will be from source to observer. Done? Okay. Now, I will take another question which is again very important. That is the policeman and thief question. So this is one, okay. In Dhoom, okay. After that, okay, this is the bike now, and he's running on this bike, and policemen are trying to catch in their car. Okay, this is the policeman, and this is the thief. Both are moving in this case in same direction, and when they are moving in the same direction, then we cannot easily figure out which one is approach, which one is the recession. So what we will do, suppose policeman is making the horn. If this becomes the source, then this is the your observer. Whoever will make the horn, that will be the your source. Like they will say that police, okay, they are saying in this one that police makes horn of 500 hertz. Okay, if 500 hertz they are making the horn, then find frequency observed by the your thief here. So we can say this is the source, this is the observer. In this case, if you say observer trying to go away or towards, from this source, observer is trying to go away or towards, it is trying to go away. And when it is trying to go away, then we can write upper side away. Na? Away means upper side will be minus. And if both are moving in the same direction, then sign will be same. So we can write here in this case, and dash will be equal to here, and V minus VO divided by V minus VS, and then we have to just put the your okay values in this one. So we can write here in this one, this is your 500. V will be given to you, that is the your suppose 330. VO, this will say that this is moving with the 20 meter per second. This one is moving with the your 30 meter per second. So observer is your 20. So you can put here your 20 in this one, and here you have to just put your 30. In these questions, when both are moving in the same direction, then sign will be same. Okay, upper side if minus, then downside also minus. If upper side plus, then downside also plus. And how to decide will be the minus, 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 or plus, plus. If observer is trying to go away, then we'll try it upper minus, so down also will be minus if both are moving in the same direction. Sometimes what will happen, suppose this is the source, this is the observer, and if in this case, okay, they are moving like this, means this is the observer. Here observer trying to get close, and if observer trying to get close, so we can say in this case observer is trying to get close, so it will be plus, so both side plus, so and is equal to, we can write here V plus VO divided by V plus VS. So observer will decide whether it will be the plus or it will be the minus, but when both are moving in the same direction, then sign will be same, upper and lower sign will be same. So observer, okay, moving away, minus, minus, observer trying to get close, plus, plus will be there. Okay, so these are the two questions. Okay, one is the before crossing, one is the this one, that was somewhat important that you have to remember in this one. And now next thing I can go for your okay, Bernoulli, actually very important. In Bernoulli, this thing is okay, horizontal flow is very important. This figure, first of all, equation of continuity everyone knows, A1 V1 equal to A2 V2. And if they ask here in this one, okay, that here area is more and here area is less, so here velocity is V1 and here velocity is V2, so which velocity is more, you have 100% clear idea. Okay, in this one, that is the basically here, okay, in this one. So we can say V2 is 100% more than V1. But about V2 is more than V1, there is no problem. But if here pressure is P1, here pressure is suppose P1, and here pressure is P2, then which pressure is more? Then, okay, pressure is basically, okay, inverse you have to remember. Okay, here one relation is there that I cannot explain now. Okay, so you have to remember here pressure is, okay, in this one more and here pressure is less. So P1 is more than P2. Reverse thing is there. If I say here it is one, okay, if I draw one, okay, capillary here liquid will rise more and here liquid will rise less. This thing you have to remember. Relation is there, okay, that I cannot say. And you have to remember here delta P, pressure difference, which is given by P1 minus P2, is given by this relation half rho V1 square minus V2 square. This is used in multiple questions. In your notes also you have seen. So delta P, which is the P1 minus P2, is given by half rho V1 square minus V2 square. Okay. They will say in this case that here, okay, here velocity is your 200, here velocity is 100. What the pressure difference between these two sections? Or pressure difference will be given. Like I will say, delta P equal to, suppose they have given 2000 Pascal is given, okay, and then they will ask, okay, they have given A1 equal to, okay, 2 and A2 equal to, they have given suppose 1. Like this they have given. And then they will ask, you can say you will use this relation. So we can write 2000 equal to half, rho is how much? Your 1000, V1 and V2 not given. So we can say in this one, A1, A2 is given. So I will use this A1, V1 equal to A2, V2. A1 is how much? Your 2, V1 is your V1 equal to, we can say A2 is your 1 into V2. So you can say V2 becomes how much? Your V2 is just 2 V1. Here we are in a P1, so here V2 will be more, so V2 minus V1 actually we have to put here. So now we can say V2 we got 2 V1, so we will write here 2 V1 square means 4 V1 square minus V1 square, and then we can just say 3 0 cancel, so this will be how much? Your 4, so 4 equal to, this will be the 3 V1 square. We can calculate your V1 and V2. So this formula you have to remember. Maybe this formula can be asked, or this diagram can be asked in this one. Delta P half rho V2 square minus V1 square. I will take one question on the your aeroplane also, because this thing is used in the aeroplane. They will say the wings of aeroplane, okay, upper side velocity is basically your more. So here velocity is suppose 100 meter per second, and here velocity is 60 meter per second. So here velocity more, so pressure will be less. And here velocity is less, so pressure is more. So here pressure will be more, so here force will be more. It will lift upward. Okay, this is the short introduction of this thing. Here pressure is, here velocity will be more at upper part of the wing. Velocity is okay more, so pressure will be less. And here velocity is less, so pressure will be more. Now we can say they will ask what are the pressure difference. So we'll use this formula half rho. We can write here in this one your V2 square minus V1 square. So half rho value will be given. I'm not putting here in this one what is the rho value, and then you can say this will be V2 square minus V1 square. For the calculation purpose, always you will use this thing V2 plus V1, and here we can write V2 minus V1. So we can write here half rho 100 plus 160 means 160, and here we can write how much? Your 40. Rho value will be given. You can find delta P. If they are asking the force, then we can write delta P into A. That will be the your force in the aeroplane. At least aeroplane type question you have to do clearly. I will ask one more question on the aeroplane here. I hope this one is clear. Formula is this same. That previous one question was like the venturimeter type question. This one is known as venturimeter type question. That becomes somewhat higher side. But aeroplane is very simple model. Delta P half rho V2 square minus V1 square, and then we have to put the values. Next question, if I say, they will say here velocity is V, and here velocity is root 5V. Upper side velocity is root 5V, and downside velocity is how much? Your V. Now they are asking, so we can say again delta P equal to half rho V2 square minus V1 square. So half rho V2 square, if you say, then root 5 square will be how much here? 5V square minus V square. It actually becomes half rho into 4V square. That is actually your 2 rho V square. That is the delta P. If they ask the force, then we can write here delta P into A. It becomes 2 rho V square A. They might ask like this. Here calculation is also not there. Here V, here root 5V. No calculation. So half rho V2 square minus V1 square. V2 means which one is the bigger one? Root 5V square, 5V square minus V square, and then half rho into 4V square. Okay? Yes? Okay. I hope this is aeroplane model you can do. Velocity of efflux is nothing. Velocity of efflux is root 2gh. So I'm not saying anything on this velocity of efflux things. Now, capillary rise, you have to remember that formula of capillary rise, first of all, H equal to 2t cos theta divided by r rho g. Okay, 2t cos theta by r rho g. In which case it will rise, okay, based on the shape of this one. If it is like this, it will rise or fall. This shape you have to remember. It will rise or fall. Here if you see your angle is less than 90, here theta is less than 90. And when it is like this, it will always rise. So this one you can mug up first of all, that like this, where angle is less than 90. In this case, it will rise. They will give you three shapes and they will ask in which it will rise, in which liquid will fall. Because formula is same for all type, okay? If it is like this one is given. When like this liquid is having this shape is known as concave. Okay, if you touch now, you will feel concave. If concave meniscus is there, okay, this shape is known as meniscus. Concave meniscus, it will rise. This is your convex. So convex, it will fall. And if you say angle here, then this contact angle will be more than 90. So this one you have to remember. When it will rise, when it will fall, because for both cases formula is same, 2t cos theta by r rho g. Okay, and in this one you can say h is proportional to 1 by r always. Okay, h is proportional to 1 by r, and graph of h and r will be like, okay, this. Now, so shape of meniscus in this formula. Now in this formula you have to put the values. If cos theta is not given in the question, it is 1. If not given, then by default you will take 1. If given, you will take that value, otherwise 1. And formula is same. Okay, when it will be your rise, it will be always less than 90, so it will be positive. And in the rise, if they have given, suppose your fall, it will be more than 90. Okay, so that will be coming as negative. But shape of meniscus, you have to remember that when it will rise, when it will fall, in both case formula is same. Okay. Now, then comes last point here. If they have given some drops are combining and they are making the bigger drop, this thing is used in your nuclei also. They will ask that nuclei can be explained by the liquid drop model. Like few small nucleons will combine, they will make this nuclei, and then this bigger nuclei you can again break. And how you can break? Whenever you will supply the energy to this one. So here energy in this case is absorbed. Okay, again it will come to this small drops, and here in this one energy should be released. And why it have to release the energy? Because if it want stable structure, they are small. Okay, here in this one all are okay. If they are forming this bigger one will be ultimately unstable. If it have to be stabilized, then it need to release the energy, then only it will be stabilized. When they are coming together, they will be unstable, so they need to release the energy, then only they will be stable. So here energy will be released. Formula for energy is same in both the process, only energy release or absorb. And this one just you have to remember here, 4 pi r square t and power 1 by 3 minus 1. Okay, and here r is the radius of bigger one. Okay, always 4 pi r square t and power 1 by 3 minus 1. They will ask here one question, I can see. A drop of 6 mm, okay, divides into 27 smaller drops. Okay, smaller drops. How much energy will be released? Same formula you have to use. You can write here 4 pi r Capital R is your 6, so you will use same thing. I am putting here R equal to, you will put 6 into 10 power minus 3 meter. This value you have to keep here. And then we get T 27 power 1 by 3 minus 1. This is the 3 minus 1, which is the basically your 2. 2 into 4. Answer will be here 8 pi R square T. Mostly they are not putting values also. So you can do these things. And now, okay, now turn for the your track 1. Sir is already waiting. So, okay. So bye and do all the things. Okay. First of all, you have to mug up all the formula for each chapter. Okay. Enjoy. Bye.